Okay, the next topic is determining whether a function is increasing or decreasing on an interval. So I have to define what does it mean for a function to be increasing or decreasing on an interval. And this is very similar to the definition of the average value of, or the average rate of change of a function. The average rate of change of a function is only defined on an interval. The same happens on determining whether a function is increasing or decreasing. You cannot say that a function is increasing or decreasing at a single input. Right? So it wouldn't make sense to say that a function is increasing at x equals 1. Right? That's not defined. And I'll give you a precise definition. Right? But you could say something like the function is increasing on the interval 1 to 3. Right? So anytime you think of average rate of change or intervals in which the function is increasing or decreasing, you always have to be working on an interval. Like I said, I'll give you precise definitions in a moment, but it's very easy to tell whether a function is increasing or decreasing by just looking at its graph. So here I have an example. Example 4, determine on what intervals is the following function increasing or decreasing. And basically, it's very easy to determine. What you do is, you can do it this way. Think of drawing over the graph that's already drawn here. So let me do that in red, and not with a solid line, but with a dotted line. As you're drawing the graph, if your pencil is moving upwards, then the function is increasing. Right, so if you notice, as I go from negative infinity to a, and here assume that this function just keeps going down all the way, to x equals negative, as x approaches negative infinity. Right, so as I move from left to right, from negative infinity to x equals b, as I move from left to right, my pencil is moving up, as the function is increasing. However, once I reach b, and I don't need a here, once I reach b, something happens. Notice that as I move on from b and I draw my graph, now my pencil is moving downward. And that kind of explains both of the behaviors. As you draw the graph, you're either going to be moving your pencil upward, in which case your function is increasing, or you're going to be moving your pencil downward, in which case your function is decreasing. And again, you always trace the graph working from left to right. So always from negative infinity to positive infinity. Okay. So if I were to write on what intervals is this function increasing, just from what I've done so far, let's give the function a name, f of x. Right. So from what I have so far, f of x is increasing on. So we saw that as we draw the graph from negative infinity to b, and it's increasing because we're moving upward as we trace the graph from left to right. Since we never want to include, since we never want to calculate or say that a function is increasing or decreasing at a specific input, we always work with open intervals. Right? So an open interval is an interval in which both endpoints are parentheses. So always work with both endpoints being parentheses. Again, because we don't want to try to define what it means for a function to be increasing or decreasing at a single input. So always use open parentheses for the endpoints. Okay. Now, we're going to do this part by part. So f of x is decreasing on, for it to write on. So as we saw, as we move from b towards the right, as we draw the graph or trace the graph, our pencil is going down and down until we reach x equals c. So this function is decreasing from b to c. Again, always using open parentheses. Now what happens when I get to c and I move towards the right? Right? Again, if I trace the graph, my pencil is moving upward. Still moving upward, still moving upward. Oops, I went a little bit too far above the function there. Right. Until I reach x equals d. Okay. So from that, I can see that the function is increasing on the interval c to d. I want to include that with the interval that I drew previously, or that I wrote previously. We know how to do that. We use the union symbol. Right, so union c to d. Okay. Now let's see what happens as we move towards the right of D. Again, I trace my graph. Now my pencil is moving downward. Right? So the function is decreasing, and it keeps going on like this until forever. Right? So based on that, our function is also decreasing on the interval D to positive infinity. And that's basically how it works graphically. Very easy. Just trace the graph. Anytime where your pencil is moving upward, or where you see that the picture of the graph is going upward, then your function is increasing on that interval. Anytime as you trace the graph, your pencil is going downward, or you can tell that the y values are getting smaller as you're moving from up down, then your function is decreasing on that interval.